Hello everyone! I just wanted to highlight a few things that will be most helpful to you in this chapter. Let's jump right in. So I wanted to start with a thought experiment here. We have two people. One person is pushing a shopping cart and the other person is pushing this big dump truck. Now let's assume that the wheels in both these are very frictionless, and so we're not to worry about any drag or anything here. Which one of these is harder to start moving and why? Now, your obvious choice is going to be that it's going to be harder to get the dump truck to start moving, and you would be right. But the question is, why would that be the case? You would be tempted to say that, oh, gravity, this weighs a lot more, so clearly it would be harder to get going. Well, the force of gravity is directly downwards. How would that prevent you from being able to push it horizontally? And here we have completely flat ground. It's not like you're trying to push it uphill or anything. So because those are perpendicular to each other, they're not really going to affect each other. And the truth is, mass has another very weird property alongside gravity, which makes it harder to get the dump truck to start moving than this empty shopping cart here. And that property is called inertia. So this is the resistance to change in velocity. Now, more mass means more inertia. So mass now has two very separate properties here. Inertia, which is the resistance to change in velocity, and weight or gravity. This is the force of attraction between objects with mass. So two very separate properties, but they both come from mass. Now the units of these are also a little bit different. The units of inertia are in kilograms, which is the same unit as mass. And the units of weight or gravity is in newtons, which is the same unit that we use for all forces. So Newton did a lot of work with this and was able to come up with an equation that will allow us to solve with numbers. So here we have that the acceleration of an object is equal to the net force on that object divided by its mass. Now the mass here, this is the inertia property of mass, the resistance to change in velocity. And this net force is, this is all the forces acting on the object added together. So we can't just look at one force here or there, look at all of them added together. So the net force on that object will tell us the acceleration of the object if we have also the inertia mass of that object. All right, let's do a little concept example here. Let's say I have a hand that's going to be pushing this brick across this very smooth surface, so think like ice, okay? So this hand accelerates this brick. Let's say I use two hands now. So I want to know, how has my acceleration changed here compared to when I was doing it before? Well, if we look at our equation here, Newton's second law, if I'm using two hands, I'm doubling the force on that object, but the mass hasn't changed. So if you double the numerator without changing the bottom, our acceleration is going to be twice as big. So here the acceleration is going to be twice as much as it was over here. Let's do the same thing down here. Let's say instead of one hand in one brick, I go one hand in two bricks. So here the force it's now still the same, but the mass has now doubled. So because the denominator is now doubled, the acceleration will be half as much as it was before. So this acceleration is half as much as it was with one hand in one brick. And finally, what if I do two hands and two bricks compared to one hand and one brick? Well, if I'm doubling the force, so I'm doubling the numerator, and I'm doubling the mass, so I'm doubling the denominator, those two are going to cancel each other out. 2 over 2 is 1. So my acceleration here is going to be the same acceleration as it was with one hand and one brick. Let's move on to an equation with some numbers. So here I have this box, and there are two horizontal forces acting on it. There's 8 newtons to the right and 10 newtons to the left. And let's say that the box has a mass of 2 kilograms. Now for now, we're just going to look at the horizontal forces here, okay? And the first question I have is, what is the net force in the box? Because remember, we need the net force in order to get the acceleration. So it's kind of two questions in one that we'll get to here. Well, we're always going to choose the right to be the positive direction. So here I have 8 newtons to the right and then 10 newtons to the left. So because of that, our net force is going to be all the forces to the right minus all the forces to the left. So that gives us, we only have one force to the right, so that's 8 newtons, minus only one force to the left, which is 10. So we get 8 minus 10 is going to be negative 2 newtons. So again, the negative here just means to the left. So the net force is 2 newtons to the left, or when we plug this into an equation, it's going to be negative 2. And finally, what is the acceleration of the box? So acceleration is the net force over mass, just like the Newton's second law tells us. So we can just plug those numbers in. Net force is negative 2, like we just solved. Mass is 2. That's the 2 kilograms that we're told in the problem. So our acceleration is negative 1 meter per second squared, or 1 meter per second squared to the left. All right, I hope this highlight has been helpful. Let's get to it.